deals with radian measure. So you've always worked on your calculators, and we always had these degrees and radians and not know what the radian actually means. So we're going to learn about it today.
Oh, wow, that's pretty good.
Okay. So much similar to the analogy I use is miles and kilometers. All right. We have different ways in which we can describe the length of a distance. So miles and kilometers. We have different ways in which we can describe angles as well, and that is degrees and radians. So a circle has 360 degrees when you go around the circle. If I make the radius 1, the circumference of the circle becomes 2 pi times 1. So the circumference of the circle, so the distance around the circle is 2 pi. Radians describes the length of the arc rather than the angle itself. So if I have an angle here of 30 degrees, okay, I can describe the length of the arc here as a portion of the 360 degrees. But instead, I'm going to describe it as a radian measure. So the long and short of it means this, that the distance around the circle is 2 pi radians is equivalent to 360 degrees. If I divide both sides by 2, pi radians is 180 degrees. So straight across the circle, that arc length is pi radians. It's also 180 degrees. So to find out what any portion of the circle is, the arc length of the circle, I use this ratio right here to change it. So I would go 30 degrees times pi over 180 degrees, because that's the ratio. Pi radians is 180 degrees. 2 pi radians is 360 degrees. So I reduce this fraction, and 30 degrees is pi over 6 radians. That's the answer. Okay? So that describes this arc length right here. So rather than using the degrees, I can use a radian measure.
So all you did there was divide 180 to 530.
Yeah. It's reducing the fraction, right? This would be 30 pi over 180, right? So 3 over 18 is pi over 6, 1 over 6. Okay? Radian measure is an alternative way to express the size of an angle. Using radians allows you to express the measure of an angle as a real number without units. The central angle formed by one completion revolution, 360 degrees, is 2 pi in radian measure. Use benchmarks to estimate the degree. We don't need to use them. So it says estimate the value of 120 degrees. So what I do is I go 120 degrees times pi over 180 degrees. So that's like 12 pi over 18, and I reduce to 3 pi.
Yeah.
No,
2/3.
2/3, that's right. 2 pi over 3. Yeah.
Could you also divide 120 by 180 to ratio, whatever you get there, times that by 5?
So as you said,
So that's the percentage of it, right?
Yep. Yeah. Okay. Estimate the value of 220 degrees. What am I going to estimate? I'm going to find out what it actually is. 220 degrees is pi over 180 degrees. So that's 22 pi over 18, which is 11 pi over 9. Okay? Now, the one thing we have to, when we have the pi value, we leave the pi in there and it keeps it as an exact value. However, pi is a number. So in theory, if I took 11 times pi divided by 9, I could end up with the same radian measure. So punch that into your calculator, put it to 3 decimal places, so 11 times pi divided by 9.
Uh, 3.8, I guess 3.840.
So I can describe that as an exact value of 11 pi over 9 or 3.840 radians. And if I look at the circle, (220 degrees takes me somewhere down there. That spot.
So you just divide it by quarters? So for a second.
I always, yeah, say by quadrants. Yeah. I always start with my terminal arm. This is called the terminal arm right here. It starts on the x-axis, the positive x-axis, and goes counterclockwise to make the angle. Okay, so we'll do a little more with that. Yeah, go ahead.
That's a good circle thing.
Or question,
Yeah, we're gonna go.
No. What circle?
What
The
question?
radius circle.
to get full marks, do you need to do all those steps?
Quiet for a second.
For a question, to get full marks, do you need to do all those steps, or could I just do 320 divided by 180 times?
I don't care how you get to 11 pi over 9. You gotta get to 11 pi over 9.
You can't get to this.
We don't want this. If I have pi as part of my,
Okay.
yes, you want to do this out. All right, so Royce just mentioned the unit circle.
Is this
We
necessary?
don't have to do the unit circle,
Thank you.
but I'm going to use it to show you because we do have to graph sine and cos. And we have to do sine and cos regression graphs. So, first things first is I'll show you the main parts of the unit circle. And the thing about the unit circle this time around in the applied class is I don't need to know my ratios. Okay? All I need to know is my radians and my degrees and mostly degrees. Okay? So this is 0 degrees right here. 90, 180 degrees, 270 down here, right? Okay. Now, the coordinates I do need to know are the quadrantal coordinates. That's these coordinates here. So that coordinate there is 1 and 0. This coordinate up here is 0 and 1. This coordinate right here is minus 1 and 0, 0, and negative 1. Okay. So far, so good. Now, I'm going to write this down. Okay. The x value of the coordinate is the cos ratio. The y value of the coordinate is the sine ratio. So if I said to you, I need to graph y equals sine theta. All right, it's the y coordinate. So starting at 0, what is the measurement of
Oh, 0.
0 degrees is 0. And then at 90 degrees, it's 1. At 180, it's 0 again. At 270, it's negative 1. And at 360, it's back to 0. This is your sine graph. Okay? So all of these coordinates, these 5 key coordinates, come from the y values of those coordinates. The cos come from the x value of those coordinates. So where does the cos graph start at? Starts at 1. Then goes to 0. Then negative 1. Back to 0. And back up to 1. So the cos graph works like that.
And it would be like a never ending thing of it just going up and
That's
that
right, it
way.
goes forever. That's correct. Okay, so they all these 5 coordinates come from the x values for cos, and the sine value is the y values. Okay, these are called periodic functions. They repeat every 360 degrees. They start back over again. Okay? So if you look on page 208, there's some important pieces of information on 208 that you need to know.
Oh, shit.
Okay. The graphs of these 2 periodic functions have the following common characteristics. They have multiple x-intercepts. So you can see that they go forever. So your x-intercepts occur on the blue. So for y equals sine theta, they're at 0, 180, 360. So every 180 degrees, you have an x-intercept. For cos, the zeros occur at 90 degrees, 270, and then every 180 degrees after that. So there's multiple x-intercepts. Each one has one y-intercept. It only crosses the y-axis one time. What's the y-intercept for sine theta? Is it?
No, 1.
For sine?
0.
0. That's correct. So 0. The y-intercept for the cos of theta is 1. The domain for both of these. Domain, x is an element of all reals. Okay? Because it goes forever. The range for this guy,
Y is greater than or equal to -1 less than or equal to positive.
right, so -1 less than or equal y, less than or equal to 1. Y is an element of all reals. So the lowest it goes is -1, the highest it goes is +1 on those graphs. An amplitude. Amplitude is the maximum distance from the x-axis. Okay, so what is the amplitude? It's from here to here, which in this case is 1. So they both have an amplitude of 1.
Would it become -1 or would it just
No.
be like the distance?
Amplitude is an absolute value distance.
Okay, so it's just like,
Okay. We refer to the x-axis as the midline. So the amplitude is actually from the midline to the top, or the midline to the bottom. It has a period. So where it starts to repeat, that distance, that x distance, is your period. In this case, for both of them, it's 360 degrees. They start to repeat. This guy goes up and to the right from the midline, here and here. So therefore it repeats. So we can write it as 360 degrees or 2 pi. A midline defined by the equation y equals 0. This midline is the horizontal line halfway between the maximum and minimum values. The 2 graphs oscillate about this line. The period is the length of 1 cycle. Okay. I'm just making sure we've got everything covered here.
do we have the unit circle and pre-calc within this one?
A lot.
A lot.
Why?
A third of the course.
So,
Okay. The midline, they give you this on page 210. The midline can be found. It's the equation of the line. Y equals your maximum plus your minimum divided by 2. So that's the equation of your midline.
So can you not just have, oh, I guess they're not always equal, hey?
Alright, that's it for today. I don't want to go too much further. Got people missing, so you can work on 8.1 and 8.2. 8.2 only has one question. So you can start it on 8.3 as well.
Can you leave your notes on? Can you leave notes on the board so I can continue to wait notes?
Yes, Eli.
Washroom.
Okay.
Oh, my taking pills in my hair.
Did you see him on Edmore Road?